Hello everyone. Today we are going to learn about Amazon's Elastic File System, or EFS for short, one of AWS's core storage services. EFS is designed to provide scalable, fully managed shared file storage for AWS workloads, and unlike block storage like EVS, which is attached to one instance at a time, EFS can be mounted by multiple EC2 instances simultaneously, allowing them to share data easily. We'll explore how EFS works, its key features, its use cases, and how it differs from other storage types such as EBS and S3. By the end, I hope you'll be able to understand where and why EFS fits perfectly in AWS's storage ecosystem. Amazon EFS is a serverless elastic file storage system built to handle dynamic workloads. It automatically scales capacity as files are added or removed, so you never need to provision or manage storage size manually. EFS supports the NFS version 4 protocol, which allows multiple EC2 instances, even across availability zones, to connect to the same file system simultaneously. This shared access makes EFS ideal for applications where multiple servers need to read and write to the same data source. It's most commonly used for Linux-based workloads, but it can also be accessed from on-premises data centers using AWS Direct Connect or a VPN, making hybrid architectures possible. Here's how EFS operates at high level. You first create an EFS file system inside your virtual private cloud, VPC. Each file system can then be mounted on EC2 instances using standard Linux commands, just like any other NFS drive. Behind the scenes, AWS automatically replicates your data across multiple availability zones, ensuring high availability and durability. This means even if one zone goes down, your files remains accessible. EFS dynamically scales both up and down depending on how much data you store, and you only pay for the actual storage used. That elasticity makes EFS perfect for variable workloads where usage fluctuates. EFS offers two performance modes, and your choice depends on your application's needs. General purpose mode is the default option. It's designed for low latency workloads such as web servers, content management systems, or small-scale applications that need fast response times. Max I/O mode, on the other hand, is optimized for massively parallel workloads with hundreds or thousands of concurrent connections. It delivers higher aggregate throughput, but with slightly higher latency. You select a performance mode when creating the file system, and it defines how EFS handles requests, concurrency, and overall speed. Choosing the right mode ensures you get the best balance between performance and scalability for your workload. Let's take a closer look at the two EFS storage classes in more depth. EFS Standard is the default class when you create a new file system. It stores data redundantly across multiple availability zones to ensure durability and high availability, making it ideal for mission-critical, frequently accessed applications such as web servers, content management systems, or shared deployment environments. It provides the lowest latency performance but comes at a slightly higher cost since the data is constantly active. EFS Infrequent Access, IA for short, by contrast, is built for files that are rarely read or written. For example, archive logs, historical data, or older project files. It's much cheaper, often around 1/10 the price of standard, but has slightly higher access latency and a per gigabyte retrieval fee when the data is used again. The real magic happens, of course, with Lifecycle Management. This feature monitors how often each file is accessed. If a file remains untouched for a specified duration for 30 or even 60 days, EFS automatically moves it from standard to IA. If that file is accessed later, it's transparently transitioned back to standard. This happens at the individual file levels, so active files stay fast and inactive ones quietly move to cheaper storage. You can adjust the lifecycle policy 30, 60, up to 180 days based on how your data behaves. In effect, Lifecycle Management gives you a hands-free tiering system, ensuring that you are only paying high performance rates for the files that truly need it, while long-term or idle data stays in the cost-efficient tier automatically. Let's look at a practical example of EFS in action. Imagine you are running a load-balanced web application across multiple EC2 instances. Each instance serves users but needs access to the same set of application files, static assets, or configuration data. By mounting the same EFS file system on all instances, each server sees the same file structure in real time. This ensures data consistency and allows auto-scaling groups to launch or terminate instances dynamically without data synchronization issues. Since EFS is available across multiple zones, it also ensures fault tolerance. Even if one zone experiences an outage, the application remains operational. Here's a quick comparison to help position EFS among AWS's other storage devices. EBS is block storage. It acts like a hard drive attached to one EC2 instance at a time. S3 is object storage. It's accessed via APIs and is great for large unstructured data like images, backups, or static content. EFS sits in between. It's shared file storage accessible by multiple EC2 instances simultaneously using the NFS protocol. In short, use EBS when you need storage for a single instance like a database volume. Use S3 for large-scale object data or static web hosting. Use EFS when multiple instances or users need shared real-time file access. EFS is extremely flexible and supports a wide range of workloads. For web and CMS platforms like WordPress or Drupal, EFS provides a shared directory where all instances can read and write data simultaneously. In big data and analytics, EFS can store large datasets that need concurrent access by multiple compute nodes. In CI/CD pipelines, developers can use EFS to share build artifacts or logs between build servers. EFS also integrates seamlessly with AWS container services like ECS and EKS, providing persistent shared storage for containers. Finally, in machine learning or media processing, EFS enables high-throughput data sharing for distributed compute clusters. And this is the end of the video. See you in the next one. Please like and subscribe and take care.